Good morning or afternoon, whenever you're watching this. Today we're going to talk about ratios. So we're just going to talk about what are ratios. Yesterday you should have watched a few videos introducing you to ratios. So basically a ratio compares two types of number or two types of objects. And this is with numbers. So, for example, like I said yesterday, I have two brothers. So the ratio of boys to girls in my family is 2 to 1. Okay. So we're going to talk about how ratios can be written in 3 different ways. So they can be written as x to y with a colon, x to y, and then x over y. Okay. Those are just the 3 different ways to write ratios. You need to be familiar with those so that you can recognize a ratio when you see one. And we say it as x to y each time. Okay, so if we have these shapes here, we're just going to answer some basic questions about the relationship between these shapes. So the first question here asks us, what is the ratio of squares to circles? Okay, so we want to find the number of squares, 1, 2, 3, 4. There are 4 squares to 1, 2 circles. Okay, so that's one way to write it. We could also write it 4 to 2 or 4 to 2 as a fraction. Now I always have to write it as the 4 first and the 2 second in this case because it's specifically asking us for the ratio of squares to circles. So that order that the question is asked in tells us the order to write our numbers in. Now we're going to talk about equivalent ratios some tomorrow, but let's just talk about this right here. So if we have a ratio of 4 squares to 2 circles, that means every time we have 4 squares, we have 2 circles. But if we look at it like this, I can cut both of these ratios in half, or both of the numbers in half, and now I have a ratio of 2 squares to 1 circle. Is that equivalent? Yes, it is, because just like with fractions, if we divide both parts of our ratio by the same number, we get an equivalent ratio. So we're going to talk more about that tomorrow, but I just want us to think about how this is also a way to describe the number of squares to the number of circles. Okay, let's look at this question right here. What is the ratio of squares to total shapes? Okay, so this time we are going to take a look at the number of squares and compare it to the total shapes. So the number of squares, once again, is 4. Okay, and then the total shapes, I want you to think about it. Is a square a shape? Now you should have answered yes to that question. A square is a shape. And so to find the total shapes, we need to include all of the squares when we count. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 total shapes. So the ratio of squares to total shapes is 4 to 12, or 4 to 12, or 4 to 12 as a fraction. Now once again, we can reduce this ratio, and we could reduce it to, if we divide these both by 4, 1 to 3. So that means that there is 1 square for every 3 shapes. Okay, that doesn't just mean that we have 1 square and 3 total shapes. It means that we have a ratio of 1 to 3. So for every 1 square, okay, we can circle 3 other shapes. If I box in the square, I can kind of box in 3 other shapes. And then for this square, I have 3 other shapes here. Okay. And then what is the ratio of circles to triangles? So if we just answer that one real quick, hopefully we're getting the hang of this. If we wanted the ratio of circles to triangles, we first count up the circles. 1, 2. Okay, I'm going to write this down here. 2, and then how many triangles are there? 1, 2, 3, 4, 5, 6. 2 to 6. Okay, I can write that as 2 to 6. 2 to 6, or 2 over 6. Okay, I could also reduce that to 1 to 3. Okay, Those are equivalent. All right, so that's a basic introduction to what are ratios. Let's look at the next slide here. Okay, so we can use ratio diagrams to find equivalent ratios. Okay, so let's talk about this situation. If a store always stocks we're going to use a bar diagram in this case. We're going to show you what that is. If a store always stocks their footballs and soccer balls in a ratio of 5 footballs to 3 soccer balls, how many soccer balls does the store have if it has 100 footballs? So first we're going to model this situation using a bar diagram. Okay, since the ratio is in simplest form of footballs to soccer balls is 5 to 3, we will draw 5 boxes to represent the footballs and 3 to represent the soccer balls. Okay, so this is what a bar diagram looks like. So if we have footballs and then soccer balls, the footballs, there was a ratio of 5 footballs. 1, 2, 3, 4, 5. I'm going to draw 5 boxes, and then the soccer balls, I'm going to draw 3 boxes. 1, 2, 3. Okay, we know that the target number of footballs to be 100. Therefore, we need to evenly divide 100 into the 5 football boxes. Okay, so the simplest form ratio is 5 to 3, but now we need to figure out if there are 100 total footballs. How many soccer balls are there? Okay, so with the ratios, we are thinking about what can we multiply that 5 times to get to 100. And in this case, with the bar diagrams, we're going to divide 100 into these 5 boxes here. So we have these boxes here, and we need it to be a total of 100 footballs. So if we take these 5 boxes and divide by 100, each of these boxes is going to have 20 in it. Okay, so that was number 2. So step 3 says since all of the boxes in the diagram represent the same amount, we are going to put the number 20 in each of the boxes for the soccer balls. So, whoops, that was silly. We're going to put 20 in each. Okay, so 20 in each. The reason we do that is because originally each of these boxes represented 1 football and 1 soccer ball each. Okay, so the boxes have to be multiplied by the same number in order to keep equivalent ratios. As we can see from the diagram, there are 20 times 3 soccer balls, and therefore the number of soccer balls when there are 100 footballs is 60. So this is equal to a total of 100 footballs, and this is equal to a total of 60 soccer balls. So we can say that 100 to 60 is the ratio of footballs to soccer balls when there are 100 footballs. Okay, so that's a bar diagram, drawing these boxes, starting with the original ratio, in this case of 5 to 3, and then dividing what we know into those boxes. Okay, it would have even worked if we said there were 100 total of a combination of soccer balls and footballs. We could have divided that into all of these boxes. Okay, so you just need to think about the situation that you're given. Okay, so then the last part of this is to, well, we're going to do one more example with a bar diagram, and then we're going to talk about a double number line. Okay, so a bar diagram, in this case, if an animal shelter can only take dogs and cats in a ratio of 6 cats to 5 dogs, how many dogs will there be if they have 36 cats? Okay, so we're going to set up a bar diagram. We're going to do cats and dogs. So if we look at the original ratio, there are 6 cats, so I'm going to draw 6 boxes. And then there are 5 dogs, so I'm going to draw 5 boxes for dogs. Okay, now we know how many cats there are going to be. They have 36 cats, and we're trying to figure out the number of dogs. Okay, so we're going to take that 36, and we're going to divide it into these 6 boxes. So the total has to be 36. So 36 divided by 6, that means we're going to put 6 cats in each box. And since we put 6 in each of the cat boxes, we also need to put 6 in each of the dog boxes. 6, 6, 6, and 6. So then we just add up the total number of dogs. So 6 times 1, 2, 3, 4, 5 equals 30 dogs. Okay, another type of diagram we can use is a double number line. All right, so a double number line is exactly what it sounds like. It's 2 number lines kind of stacked on top of each other, and it helps us to skip count through to figure out the answer to these questions. Okay, so if you ride your bike 3 miles in 15 minutes, how long will it take you to ride 18 miles? Use a double number line. So we're going to draw 2 number lines. I'm basically just going to draw 2 lines like this. Okay. And label the 2 number lines with what you were comparing. In this case, we're comparing miles and minutes. So I'm going to label one of them as miles and the other as minutes. Okay, we're going to draw tick marks on both of the number lines at the same places. Okay, so you can either draw straight through like this, or you can draw little tick marks like that. It doesn't matter to me which way you decide to do it. I'm just going to draw them straight through. Kind of looks like a train track. Okay, so now I'm going to label the first set of tick marks with the given ratio. Okay, so for miles, we were starting with 3 miles. And for minutes, we were starting with 15 minutes. Okay, so now we're going to skip count on both of the number lines with a number from that initial ratio. So for miles, we're going to skip count by 3s. Minutes, we're going to skip count by 15s. Okay, so we're going to skip count 3, 6, 9, 12, 15, 18, 21, 24. And then for minutes, we're going to skip count 15, 30, 45, 60, 75, 90, 105, 120. Okay. Now, when you get to the number 18 on the miles number line, the number on the minutes number line at that same place will be your answer. So it was asking us, how long will it take you to ride 18 miles? So we look and we find 18 miles is right here. Okay, and so we look down here and we see that it takes us 90 minutes to go 18 miles. Okay. It's a pretty good pace. So let's take a look at this double number line. It also tells us some other things. So we can use it to figure out, let's say I want to say, I biked for an hour. How far did I go? Okay, you biked for an hour. That's 60 minutes. Okay. Biked 12 miles. Okay. You biked for 2 hours, which is 120 minutes. You biked 24 miles. Okay, so the double number line can help to show you what some other ratios are. Okay, so that's using a bar diagram and a double number line to find equivalent ratios. So that's it for today. You're going to answer a few questions on Pearson, just looking at how to find ratios. So good luck.